So I'm going to try and explain trigonometry in a way that makes it a little bit more easier for us to understand. So we're going to be following like a set number of rules that we're just going to go over again and again, and it's going to make trigonometry a lot easier for us to understand, because believe it or not, trigonometry is actually based off of Pythagoras. So we know Pythagoras, right? We've done Pythagoras before. We've been doing it since grade 7. This guy, Pythagoras of Samos, is the one who actually gave us the idea of a squared, or short side squared times short side squared, or plus short side squared equals long side squared. The idea of Pythagoras. Believe it or not, Pythagoras didn't actually come up with the Pythagorean theorem. His followers did. So by the time the Pythagorean theorem came around, Pythagoras was like, I think, dead a couple years. And the people who followed him, called the Pythagoreans, they're the ones who came up with the Pythagoras theorem. And then they named it after him. Imagine being so famous that even after you're dead, people are still naming things after you. Yeah, that's the kind of fame you want. Yeah, so the Pythagoreans, who used to be, because he wasn't just a mathematician. Pythagoras of Samos was actually a philosopher. So there were people who followed him, and they actually named the theorem that they predicted Pythagoras. And we've done Pythagoras before, right? We're very familiar with how to do Pythagoras. And then I'm going to show you how Pythagoras actually ties in to trigonometry, which we're going to do. So before we do that, I'm going to ask you to solve for these 3 questions for me. Just questions 1, 2, and 3. Just so we remember that Pythagoras is also going to be part of what we're doing here. All right, can I give you a few minutes, and then you can just pop your favorite emoji in the chat for me when you're ready? Okay, just numbers 1, 2, and 3 for me. Okay. All right. Are we ready? Can I give you 1 more minute? How are we doing? Almost there. Okay. I'll wait. Excellent. All right. Okay, so we've done Pythagoras before, so I'm not going to, make too much of a fuss about it. So we're going to do, I'm going to skip a couple of steps because we know how to do this. All right, I'm going to go x is equal to, I can automatically do this in my calculator. I can just go x is equal to the square root of 9 squared plus 12 squared, and therefore x is equal to 15. Okay, but remember this is a theorem like we do when we do geometry, so we have to give Pythag as the reason for our theorem that we're using. Okay, we can do the same with number 2. Okay, we're just going to go x is equal to the square root of 10 squared plus 24 squared, and that will give us, therefore, x is equal to 26. Again, this is a theorem, so we're just going to go Pythag. Okay, and we can do this because that long way that we do things, that's a grade 7 thing. So we don't really need to do that anymore because we learned Pythagoras in grade 7 when we start. Okay. All right, and then we'll get into number 3. Oh, and Kat has joined us. Woo-hoo. Hello, Kat. Lovely to see you here with us today, my darling. All right, and then for number 3, we're just going to go x is equal to the square root of, it was getting very lonely in here, of 7 squared plus 3 squared. And we know that therefore x is just going to equal to the square root of 58. I know that if you put this into your calculator, you should get something like 7,6. But normally in mathematics, what we want is the most accurate answer. So we're going to leave our answer just like that. Okay. Oh no, Kat went away. Oh no, Kat, come back. Okay. Oh, I was so excited to have her for a second. All right. I'm sure she'll come back in just a bit. All right. So we know how to do Pythagoras. That's the pretty easy part. All right. So not long after the Pythagoreans came up with the Pythagorean theorem, this guy named Hipparchus of Nicaea looked at the idea of a right angle triangle, much like the Pythagoreans did, but he saw a different kind of connection. Okay, so if, let's say, for instance, we're just going to take an arbitrary triangle, and we know this because these triangles are similar, yes? So if I have a triangle that looks like this, and it has a 40-degree angle over there, and a triangle this big that also has a 40-degree angle over there. Okay, are we in agreement that this angle over here and that angle over there, both of them are 50? Yes? Are we okay with this idea? Yeah? Right? Both of them are going to be 50. It's just that one is bigger than the other, right? Good. So what Hipparchus figured out was that if these two triangles are kind of like a larger size of the other, it's the same size triangle, just one is bigger than the other, then the ratio of each of the sides is going to be exactly the same. So if he measured 1 meter on this side and he measured 2 meters on that side, that meant if he measured 0.7 meters on this side, then on this side, he was going to measure 1.4 meters. and if he measured 3 meters on this side of this triangle, he was going to measure 6 meters. And he figured that all of these were because of whatever angle we had over here. So if we take this one triangle over here, and we kind of extend it out like that to make it double the size, each of these sides are going to be in the same ratio. They're all going to be in the same ratio because of the angle that they have over here. And he tried it with many different triangles. So he took another triangle. He's like, what if we made this 30 degrees and we extended this? Does the ratio of this side and the ratio of this side match? Absolutely, they do, along with the ratio of this side. They all match. All of them match. So he figured that for all of these, the same thing is going to happen again and again and again. So he realized that each of the angles will give us a ratio that is the same for every single triangle, no matter what size that triangle is, as long as it's a right angle triangle and there's an angle attached to it in some way. And that's the beauty of trigonometry. Trigonometry actually comes from the idea of Pythagoras, but not just Pythagoras based off one triangle, Pythagoras based on every single triangle that has a 30-degree angle over there, or every single triangle that has a 40-degree angle over there, or every single triangle that has a 50-degree angle over there. All of the sides of that one triangle will have the same ratio, even if we made that triangle that much bigger. The ratio on this side and the ratio on that side and the ratio on this side is going to be exactly the same based off of this angle over there. Give me a thumbs up. Am I making sense? I think Hipparchus was a very clever guy, right? Unfortunately for them, it took them forever to figure these out. So back in the day, they used to draw every single triangle at the same ratio and measure it out, and they had a book filled with the ratios of each and every small little triangle. So they would start with one triangle, so they'd draw this side as 1 meter, and then they draw 1 degree. They would draw 1 degree, a 1-degree triangle with a right angle, and then they would measure. And then they would draw 2 degrees, and then they would measure. And then they would draw 3 degrees, and they would measure. And then they would record all of these in a book full of how much the ratio on each side is equal to. Okay, but lucky for us, they've made it a lot easier for us these days. If you guys have got your scientific calculators with you, we're going to be using this quite a lot in this particular series. Okay, so instead of Hipparchus having to do this for every single one of these, he said, if I want to compare the opposite and the hypotenuse, I'm going to use the word sine. It was actually spelled like this back then, sine. They used to spell it like that. And then the other one, cos, was actually named cosine. And tan was known as the tangent. And the reason tan is known as a tangent, we use a different color. The reason tan is known as a tangent is because that's where these two angles meet over here that make a 90-degree angle. That's called a tangent right over there, where 2 lines meet. Okay, where they only touch each other once. This over here is called a tangent. And that's where these 3 ratios come from. All right, and we now are lucky enough that we don't have to walk around with a huge book with every single degree that we need. We've got our calculator, and our calculator has the sine, cos, and tan function on them, and we can try it for every single one of them. All right, so we're going to start by learning how to label these, because they're not quite as simple as we're thinking as we're going, because when we look at each of the triangles, it's going to be a little bit difficult for us to remember them as we go, because every triangle we need a reference. We call it a reference angle. So we're going to start by naming the sides of a triangle. Now, first thing we're going to learn about is what we call any angle, right? Now, any angle, when we see it on a triangle, we know is either going to be 30 degrees or 20 degrees or 60 degrees. It doesn't matter what that angle there is. But instead of writing the actual angle, what we're going to do is we're going to give it a Greek letter. Okay, these are the most common ones that we use to represent any angle. We will either use theta, which looks like that. It actually looks like a zero with a line through it, like that. That's theta. Or you would get alpha, which looks like that. Or you would get beta, which looks like that. Okay, and normally what you see in your triangle is they will put a triangle like this. There's always a right angle involved. And then they will draw that symbol, right? And that symbol over there does mean theta, but this means that it has replaced, it's in place of any angle. Okay, we could change that angle at any time. We can replace theta, we can say theta equals 45 degrees. And then you just know that wherever there's a theta, we're going to replace that theta with 45 degrees. And welcome, Murangi, welcome, Kat. We're so glad that you guys joined us. It was touch and go there for a second. We weren't sure if anybody else was going to come through and join us. Okay. All right. So we know that if we see the symbol, a theta symbol, or if I see an alpha symbol like that, or if I see a beta symbol, I want you guys to tell me in the chat, what do these things actually represent? These symbols in the corners of my triangles, what do they represent? Okay, Murangi, I think I know what kind of school you go to, Shane. Okay, correct. Yes, absolutely, Murangi. They represent angles. We don't know what angle yet, but we know that wherever there's a vertex and two rays or two segments, there's always going to be an angle. So alpha stands for some angle. We're not sure what that angle is yet. All right, now what we're going to do is we're going to name the sides of our triangles based off of the angle that we have. All right, so if I've got theta over there, and I'm going to name my triangle A, B, C. I'm going to name it triangle ABC. I know that if this is my angle over here, the side over here closest to my angle is called something. The side that is furthest away from my angle is called something. And the side opposite my right angle, we already know this one from Pythagoras. What do we call this side over here? This long side. Do we remember? The longest side, the one across from my right angle triangle. Who remembers what it's called? It starts with an H. Give you guys a clue. Yes, absolutely. Good. It's called the hypotenuse. Lovely. It's called the hypotenuse. Beautiful. Good. All right. But not all of these are going to be the same. Now, if this is my angle theta over here, the side closest to it is called the adjacent side. Okay. The side closest to my angle is called the adjacent side. The side furthest away from my angle, this is called the opposite side. Okay, and the longest side of my triangle, always the one furthest away from, or the one opposite my right angle triangle, that is called the hypotenuse. Okay, now this is standard, what we're looking at here. But I want you guys to note here, if I said to you guys now that this is the angle theta, but over here is the angle beta, I'm actually going to put those things back in there. Adjacent, opposite, and hypotenuse. Okay. Now if I look at the angle beta over here, now if I had to figure out what each side was called in relation to my angle, what is this side going to be for my angle? It's no longer the opposite because it's right next to my angle. What is this side next to beta going to be called? The what side? Correct, Morani, absolutely. It's called the adjacent because that's the one nearest to my angle. Now, that side, this side over here, that we've now named the adjacent, that's not adjacent to beta. This side is going to be called the what side? What do we call this side over here? To my angle beta, correct. It's the opposite side. This is the opposite. Okay. And obviously this one again, the one opposite my right angle triangle is always called the hypotenuse. That one doesn't really change, not that often. It's usually the same thing. So it will always depend on the side that we've been given over here. So we're going to learn the acronym. I just want to check with you guys. Give me a yes or a no in the chat. Has your teacher taught you SOHCAHTOA? Have they taught you guys SOHCAHTOA? Yes? Okay. Kat, what about you? Have they taught you SOHCAHTOA yet or no? No, okay, that's perfect. I can quickly help you out. All right. So this saw over here, if you look on your calculator, there's a funky little button that looks like this. It looks like this. This button that looks like that. Right. That's the S in the word saw over here. All right. Then the C over here, if you look on your calculator, there's a button that looks like this. It's called cos. Okay, that's what the C stands for, right? And if you look on your calculator again, the T over here, there's another button called tan. Do you see them on your calculator? You're going to need a scientific calculator for what we're doing today. Yes? Just give me a thumbs up or a yes, ma'am, in the chat if you see them on your calculator. Okay, are we all good? Okay, you let me know, Kat, once you've seen them on your calculator. All right, they're pretty visible. You will always see them on your calculator. Good. All right. Okay, so what the sign stands for, what the O and the H tells me is that whenever they ask me for sign, what they want me to do is they want me to take the value of the O, which is the opposite side, opposite, divided by the value of the hypotenuse side. That's what the OH stands for. So the S stands for sine, the O stands for opposite, and H stands for hypotenuse. Now, same with the C over here. Cos is going to stand for the A is going to stand for the adjacent side over, and then the H will stand for hypotenuse. Kat, can you then tell me if the T stands for tan, what is the O and the A going to stand for? If we look at the way that the other two have been written.
The O is going to be for the opposite side, and then the A is going to be adjacent.
Beautifully said. Absolutely opposite over adjacent. Okay, well said. Absolutely. All right. So I'm going to be a little bit more clear. Very well done, Kat. If the question says to us, remember, this is the angle theta over here, right? If, let's say, for instance, they don't write this over here, they just write, they give us the numbers 3 centimeters, 4 centimeters, and 5 centimeters. All right, that's what they've given us over here. Now they say to us, I want sine of the angle theta. Now, I can't quickly just go to say sine is equal to opposite over adjacent. That's not going to help me. What I need to do is first figure out what each of the sides are called in relation to theta. So the first step, the first thing we always do, guys, is we must always label. That's step number one. We're always going to label. So first thing I'm going to do is I'm going to go in relation to theta. 3 centimeters is the what side? Is it the adjacent, the opposite, or the hypotenuse? This 3 centimeters is the what side? You can unmute if you want. Absolutely, Murangi. Well done. You can unmute or you can pop it in the chat. This is the adjacent side. Beautiful. This is the adjacent side, right? That side all the way over there where the 4 centimeters is, what is this side called in relation to theta? Hello, Sammy. Good, Desmarie, absolutely. That side over there is called the opposite side. And if this is my right-angled triangle, then we know that this side is going to be the hypotenuse. Okay, this is the hypotenuse. Good stuff. So when they ask me for sine of the angle theta, I know that sine is equal to the opposite over the hypotenuse side. Now, how much do we have on the opposite side? How long is the opposite side? What is the value that they've given us for the length of the opposite side? Good, that's it, Morangi. They've given us 4 centimeters. 4 centimeters over the hypotenuse. How much do we have on the hypotenuse? Good. Excellent work. So we've got 4 centimeters over 5 centimeters. Okay. All right. Now, what happens if they say they want the cos of theta? We know that cos is A over H. We know that the A stands for the adjacent side over the H, which is the hypotenuse side. So what is that going to look like? What is that? Something over something. What is that something over something? Good. Yes, Morangi, absolutely. Kat, are you with me? Sammy, I know you just joined us. I hope you're able to keep up with what we're doing here. Okay, let me know in the chat if you're lost. I'm happy to explain. Okay, so the cos of theta is going to be 3 centimeters over 5 centimeters. All right. Are we cool with that, guys? Does that make sense? And then if they ask me for the tan of theta, that's going to equal to, what is the tan of theta going to equal to? Okay, remember what tan is? Tan is going to be the opposite over the adjacent. Right, so if we look at theta, I'm going to get tan is opposite, absolutely, guys. Opposite over adjacent. And I know that the opposite side is 4 centimeters over the adjacent side, which is 3 centimeters. Okay, are we all cool? Now, check what happens. Yes, it is. But Morangi, it's okay. No, it doesn't matter. It's not an issue at all. And you'll see when we learn about graphs, you're going to learn about the sine graph, the cos graph, and the tan graph, and it's going to make sense. Okay, why it can be an improper fraction. It's okay. It's allowed to be. All right. We cool with that? It's not an issue at all. All right. Now, what happens if I say to you guys, I want the sine of beta. Now, if I want the sine of beta, I'm going to have a problem because everything I've labeled here is not for beta. I've labeled everything here for theta. So I'm going to have to relabel first. Do you see why labeling is so important, guys? Labeling is the first thing we always need to do because look what happens when we then make beta our reference. If we make beta our reference, this side now is no longer the opposite side. This 4 centimeters is now the what side? It was the opposite for theta, but in this case, in the case of beta, it is the adjacent side. And the 3 centimeters is no longer adjacent, it is now opposite. right? And the hypotenuse is going to stay the same. So I want you guys to tell me in the chat, what is the sine of beta, the cos of beta, and the tan of beta? Okay, remember to use so, ka, toa. We know sine is going to be opposite over hypotenuse. Cos is going to be adjacent over hypotenuse. And tan is going to be opposite over adjacent. All right, so tell me what these are in terms of the values we've been given on each side. All right, beautifully done. Good, good, Morangi. Good. Sine is going to be opposite, which is now 3 centimeters over hypotenuse, which is 5. No, no, we don't, Kat. You just leave it as a fraction, okay? Just leave it as a fraction, my darling. This is going to be 3 over 5. Beautifully done. Okay, leave them as fractions, my darling. There's a particular reason why, okay? We want to leave it as a fraction. And cos of beta, correct, is going to be 4 over 5. And tan of beta is going to be 3 over 4. All right. Okay, give me a thumbs up, guys. Are we all okay with the answers that we've gotten here? Yes? Everyone okay? Cool, cool stuff. Excellent. All right. So we're going to put this to practice. Okay, I have given you guys sine of theta, cos of theta, tan of theta, sine beta, cos beta, tan beta. But now, Desiree, you say that like I'm not scared, I promise. It doesn't get much harder than this, actually. You're quite lucky because this is just an intro to Pythagoras, not Pythagoras, trigonometry. Now, I'm going to do this. I'm going to name this side theta. I'm going to name this side beta. And then instead of giving numbers for each of these sides, I'm going to label my triangle. So I'm just going to say this is the triangle A, B, C, which means this side over here, this long side over here, is actually called side AB. So when you give me each of these, I want you to give me that sine of theta is equal to AB over AC, something like that. That's the answer I want. Okay, I want you guys to answer all 6 of these. Pop your favorite emoji in the chat when you're ready. And then we'll chat. I just want to double check that you guys are still with me. What is the #1 step? What must we always do before we even think about doing sine, cos, and tan? What's the first thing we always do? Step #1 is to what? That's it. Beautiful. #1, always label the sides. Absolutely, label the sides. And just to help out, I'm going to write here so, ka, toa, so we don't forget. All right. Beautiful stuff, guys. Take it away. Just remember to pop your favorite emoji in the chat, guys, when you're ready. Thanks, Marangi. I think we'll give everyone else a couple more seconds, maybe 1 more minute, and then we'll get into it. All right, peeps, I think let's call it. Let's have a look quickly at the answers that we get here. Okay, so first thing I'm going to do is I'm going to start by labeling. And I know that the first 3 questions want me to give an answer in terms of theta. So I'm going to start labeling based on theta first, right? So I'm going to say, if this is my angle theta, the side right next door, right next to it, this is my adjacent side. The side furthest away from theta, that is my opposite side. And the side opposite my right angle, that is the hypotenuse. Okay, excellent. All right, so then I'm going to use SOHCAHTOA. I know that sine of theta, or sine, is equal to opposite over hypotenuse. And I know that my opposite side is called AC. So for sine of theta, I'm going to get AC over hypotenuse is called AB. That's my first answer. Good. Nicely done, Marangi. Good. All right. The next one is cos of theta. I know that cos, according to SOHCAHTOA, is adjacent over hypotenuse. And the adjacent side is called BC. BC over hypotenuse is AB, or if you called it BA, that's fine as well. BC over AB. Doesn't make a difference. Both correct. Okay, and tan, according to SOHCAHTOA, is opposite over adjacent. And that is going to be my opposite side is AC over, opposite is AC over adjacent, which is BC. Ooh, I almost forgot the BC. All right, those are those three, the first three. AC over AB, CB over AB, and AC over BC. All right, now my next set of questions wants me to answer the question in terms of beta, which means I now have to label again. I can't use these labels that I've used over here. They don't apply to beta, they only apply to theta. So I need to move my reference. Now, beta is my reference. So this side is no longer the opposite now. This side over here is the adjacent side. And that side furthest away over there, that is my opposite side. And that side over there again is my hypotenuse side. Okay, I'm gonna remove all the pink stuff. Otherwise, we're gonna confuse ourselves. All right, now I know again, sine, yes, correct, Morangi. Hypotenuse will always be across from the right-angled triangle. Okay, all right, sine of beta, according to SOHCAHTOA, sine is opposite over hypotenuse. So the opposite this time is BC over the hypotenuse, which is AB. And cos of beta is going to be adjacent over hypotenuse. The adjacent side is now AC, absolutely AC, over AB. Be very careful. The hypotenuse is AB. And tan of beta, we know, according to SOHCAHTOA, tan is opposite over adjacent. And our opposite side is BC over our adjacent side, which is AC. All right, 1, 2, 3, 4, 5, 6. Give yourself a mark out of 6. Let me know in the chat, how did we do? How did you do out of 6? Nicely done, Desmarie. Well done. Everyone else, how did we do? Okay, it does get kind of tricky, but we've just got to follow the steps. Ah, okay. That's okay. Well done, Sammy. Kat, how did we do, my darling? Did we do okay? I think Kat might be having a bit of technical difficulties. She was getting kicked out a little while back. Okay, hopefully she's still with us. All right. Okay, so now we're going to learn one more thing, and then I'm going to call it because we've actually made it to the end of our lesson today. All right, now let's talk about what happens if they want us to find the angle instead, right? So if they say to us that I've got, I want to be strategic about this. I've got theta over here, I've got beta over there, and they tell me that this side over here is equal to 4. Actually, let me make this side equal to 4. Make this side equal to 4, and I'm going to make this side equal to 8. And I'm going to make this side a very, very ugly number. Okay, if I use Pythagoras should be able to give me this answer. Okay, so I'm going to use the square root of 8 squared minus 4 squared, and that should give me 4 root 3. So this side is 4 root 3. All right, now let's say, for instance, now the question doesn't say find the sine of theta. Because if I ask you guys to find me the sine of theta, what are you guys going to say? What is the sine of theta? you can look at it. If we look at SOHCAHTOA, how much is the sine of theta going to be? We can see it, right? SOHCAHTOA. I want sine. Give it to me as a ratio. What is it going to be as a ratio? I know here is theta. I know that this side is going to be my adjacent side. This side over there is going to be my opposite side. And that side over there is going to be my hypotenuse. Absolutely. Absolutely. It's going to be 4/8. You're correct. Opposite over hypotenuse. So sine of theta is just going to be 4/8. All right. But now imagine the question doesn't say find sine of theta. Imagine the question says find theta. Now, what did we say theta actually stands for? If they ask us for theta, what do they actually want? A what? What does theta stand in place for? A what? Who remembers? I mentioned it at the very beginning of the lesson. What do theta, beta, and alpha, what do all of these things stand in place of? Anybody remember? Do you want me to scroll back up? These Greek letters stand for? Ah, there we go. Yes, Kat, absolutely. They stand in place of the angles, absolutely. So when they ask us to find theta, they're asking for the angle. Okay. And I'm going to be very honest with you guys. I've been trying to make this trend for the longest time. And every single year, I teach grade 10, and I try to get this thing to trend, and none of you guys want to make this trend, guys. Okay. I'm going to ask you guys very nicely. You're going to make this trend for me. Whenever they ask us to find theta, or they ask us to find beta or alpha, what I want us to do is I want us to shift angle. It sounds like a fancy, like one of those fancy, salsa moves, like a shift angle. You know what I mean? Okay, a shift angle. So whenever I asked you guys, when they ask us for theta, we must shift angle. I'm gonna make shift angle trend one day. One day, it's gonna trend. Okay. Okay. So here's what I want you guys to do. Does everybody have their scientific calculator with them? Have you guys got your scientific calculator? Yeah. Good. All right. So we're going to do this. When we know that we've got the opposite and the hypotenuse. Those are the two things we've got, right? So what I want us to do is I want you guys to click on your calculator, click shift. And because the opposite and the hypotenuse would give us sine, I want you to click shift and then click the sine button. Okay, click shift, click the sine button. And what your calculator is going to do is it's going to do this. Sine to the -1, and it's going to open brackets. Yes? Now, when it does this, I want you to click the fraction button. So click the fraction button for me. Click the fraction button. And because we know that sine is opposite over hypotenuse, at the top, we're going to put in the number 4 for opposite. And at the bottom, we're going to put in the number 8 for hypotenuse. And then you're going to close the bracket and click equals for me and tell me what your calculator says.
It gave me 30.
Yes, absolutely. It gave you 30. So what this actually means, it means that the angle over here, this angle where theta is actually 30 degrees. That's what it means. How cool is that? Your calculator can actually give you the angle in that case. So if we use sine over here, our angle is going to give us 30 degrees. Okay. But it would work exactly the same if we used cos. Let me show you guys. So here's what we're going to do. We're going to do the exact same thing. So we know that theta is equal to, now, instead of clicking shift and then cos, a sign, we're going to click shift and then cos. Click shift and then click cos, and your calculator is going to do this. Cos of -1, and then open brackets. Okay, you're going to click the fraction button, but remember, cos is actually adjacent over hypotenuse. What is our adjacent side equal to? Our adjacent side is equal to 4√3. So on the top part over here, we're going to put 4, and then we're going to click square root and put 3 inside. And then at the bottom over there, we're going to put over hypotenuse, which is 8. And we're going to close brackets. And then click equals for me, guys, and tell me what your calculator says. Yes, Kat, it says 30. Again, it gives us 30 degrees. Because we are using the angle theta over here as our reference. Right. Okay, and that is the beauty of trigonometry. It gives us the same thing dependent on which ratio we use. I bet you guys that even if you tried with tan, if you click shift tan and you put in, remember tan is opposite over adjacent. If you put in, remember the opposite is 4 over the adjacent is 4√3. If you put in 4 over 4√3, watch, your calculator is also going to give you 30 degrees again. Okay. All right, and that is the introduction to trigonometry. Right, that's where we're going to stop for today. Okay, we are going to just go through the things that we've learned so far, the things that we're going to remember about today. Right. Step number 1, or the first thing we learned, is that things like theta and beta and alpha, isn't it just so cool? All of these stand in place of what? Who remembers? All of these stand in place of what?
Angles.
Angles, absolutely. Good. These stand in place of angles. Now, whenever we are given sine or cos or tan of a triangle, step number 1 is always to do what? What is step number 1? To always?
Label.
What? Absolutely. Label. That is step number 1. And then if we want to figure out the ratios, what is that funny little saying that we need to remember? For sine equals opposite of a... Yes, absolutely. We need to remember SOHCAHTOA. And this, ladies and gentlemen, is our game plan for the whole of trigonometry. We can never go wrong if we remember these things.